Hello everyone, welcome back to the channel. In this video, we are going to cover Module 1 of Database Management System, also called Introduction to Databases and ER Modeling. This module is very important for exams because many short questions, long answers, and diagrams come from this unit. So, watch the video carefully till the end. Introduction to Data and Information. In the modern digital world, data plays a very important role in almost every field such as education, business, healthcare, banking, and government organizations. Data refers to raw facts, figures, or observations that are collected from various sources. These facts may be numbers, characters, symbols, images, audio, or video. On its own, data does not convey complete meaning and cannot directly support decision making. For examples, values like 1001, Anita, and 85 do not make sense individually. However, when data is processed, organized, and interpreted, it becomes information. Information is meaningful, structured, and useful for understanding situations and making decisions. A database system is primarily designed to store large amount of data and convert it into useful information whenever required. Need for data storage and management. As organizations grow, the amount of data they generate and use increases rapidly. Educational institutions need to maintain student details, attendance records, marks, and examination results. Banks must store customer information, account details, and daily transaction records. Hospitals maintain patient histories, medical reports, and billing details. Managing such as a huge volume of data manually is extremely difficult, time consuming, and prone to errors. Searching, updating, and maintaining accuracy becomes almost impossible with manual systems. Therefore, computer based systems were introduced to store and manage data efficiently. Initially, data was stored using simple file systems, but these systems had many limitations, which led to the development of database management systems. File system approach and its limitations. In the file system approach, data is stored in separate files, and each application program manages its own data files. There is no centralized control over the data. This approach results in several serious problems. One major issue is data redundancy, where the same data is stored in multiple files, leading to store wastage of storage space. Data inconsistency occurs when the same data has different values in different files. For example, a student's address may be updated in one file but not in another. Data access is also difficult because there is no standard query language, and a new program must be written for every data request. Security is weak since unauthorized users may access sensitive data. There is no proper backup and recovery mechanism, so data loss during system failure is common. Additionally, any change in file structure requires change in application programs, resulting in program data dependencies. These disadvantages made the file system approach inefficient for modern applications. Concept of database. A database is a well-organized, logically related collection of data stored electronically in a computer system. The data in a database is structured in such a way that it can be easily accessed, managed, and updated. Unlike file systems, a database integrates related data and avoids unnecessary duplication. It allows data to be shared among multiple users while maintaining consistency and security. Databases are persistent, meaning data remaining stored even after the system is turned off. Examples include student databases, employee databases, library databases, and banking databases. The growing need for reliable data storage and management led to the development of DBMS. Database Management System (DBMS). A database management system is a software system that provides an interface between users and the database. It enables users to define the structure of a database, create and store data, retrieve information efficiently, and manage updates. DBMS also controls access to data and ensures security and integrity. Popular examples of DBMS include MySQL, Oracle, PostgreSQL, SQL Server, and MongoDB. A DBMS hides the complexity of data storage from users and provides an convenient and efficient way to interact with the database. It acts as a centralized control system that manages how data is stored, accessed, and protected. Functions and advantages of DBMS. DBMS performs several important functions such as data definition, data storage management, data manipulation, and data retrieval. It provides security mechanisms to protect data from unauthorized access and ensures data integrity by enforcing constraints. DBMS supports concurrency control, allowing multiple users to access the database simultaneously without conflicts. It also provides backup and recovery mechanisms to restore data in case of system failure. One of the major advantages of DBMS is reduced data redundancy, which saves storage space and improves data consistency. Data sharing becomes easier and changes in data structure do not affect application programs due to data independence. These features make DBMS an essential component of modern information systems. Database system environment and uses. A database system environment consists of hardware, software, data, procedures, and uses. Hardware includes computers and storage devices. Software consists of a DBMS, operating systems, and application programs. Procedures defines rules and instructions for database usage. Users of a database system are categorized into different types. The database administrator (DBA) is responsible for overall database management, including security, backup, recovery, and performance tuning. Application programmers develop software applications that interact with the database. End users access the database to retrieve or update information and may be casual users, naive users, or sophisticated users. Database architecture and data independence. DBMS follows a three-level architecture to separate user views from physical data storage. The external level represents different user views and provides security by restricting access. The conceptual level defines the logical structure of the entire database, including entities, attributes, and relationships. The internal level describes how data is physically stored on storage devices. This architecture supports data independence, which means changes at one level do not affect other levels. Physical data independence allows changes in storage methods without affecting the logical structure, while logical data independence allows changes in the database schema without affecting users' view. Data model, schema, and instance. A data model defines how data is structured, related, and constrained in a database. Common data models include hierarchical, network, relational, and object oriented models. The relational model is the model most widely used and represents data in the form of tables. A schema is the blueprint or design of the database and rarely changes, while an instance represents the actual data stored in the database at a particular moment and changes frequently. Entity Relationship ER Model. The ER model is a conceptual data model used for database design. It represents real world objects as entities, their properties as attributes, and associations between entities as relationships. Entities can be strong or weak depending on whether they have a primary key. Attributes describe entity characteristics and may be simple, composite, single valued, multi valued, or derived. Relationships define how entities are connected and have cardinality and participation constraints. ER diagrams provide a clear graphical representation of database structure and are created before implementing the database in a DBMS. Module 1 of DBMS provides the foundation for understanding how data is stored, managed, and retrieved efficiently. It introduces essential concepts such as data, databases, DBMS architecture, data models, and ER modeling. A strong understanding of this module is crucial for learning advanced DBMS topics like SQL, normalization, and transaction management. Mastering these concepts ensures better system design, improved problem solving skills, and strong performance in examinations. Thank you.